Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve these two problems using the concepts of chain rule for derivatives. So let's start with the problem on the left side. So we have to find prime of h at 2 given h at x equals f at g at x and f at u is equal to u squared minus 1. G at 2 is equal to 3 and prime of g at 2 is equal to -1. Now we are given that function h at x is a composite function. So here we'll have to use chain rule to find the derivative of the function to find the prime of h at 2. So let's start with the derivative. So the given function is h at x equals f at g at x. So in this function, the outer function is function f and the inner function is g at x. Now in order to find the derivative, so we'll use the chain rule, and as per the chain rule, we have to find the derivative of the outer function times, and then we find the derivative of the inner function. So the derivative of h at x, so prime of h at x will be equal to prime of f at g at x times prime of g at x, the inner function. Now we have to find the prime of h at 2, so we'll sub in x as 2 in this equation. So prime of h at 2 equals, so prime of f at g at 2 times the prime of g at 2. Now we are given in the problem that g at 2 is equal to 3 and prime of g at 2 is equal to -1. So we can sub in these values. So prime of h at 2 equals, so the prime of f at 3, because g at 2 is equal to 3, times the prime of g at 2, which is equal to -1. So g at 2 is equal to 3 and prime of g at 2 is equal to -1. And now we can simplify this expression. So the prime of h at 2 is equal to negative prime of f at 3. Now we have to find the value of prime of f at 3. And for that, we'll use the given function f. So we are given that f at u is equal to u squared minus 1. So the first step here is to find the prime of this function. So we have to find the derivative, and for that we'll find the derivative of the terms u squared and -1. So we get prime of f at u. Now the derivative of u squared is equal to 2u as per the power rule. So we'll move the exponent 2 to the front and we'll subtract 1 from the exponent. And then minus 0. So 1 is a constant, so its derivative is equal to 0. So we can simplify this expression to, so prime of f at u equals 2u. Because in the exponent 2 minus 1 is equal to 1, and we don't write 1 as an exponent. Now we have to find the value of prime of f at 3. So now we can sub in u as 3 in this derivative of function f. So we get prime of f at 3 will be equal to 2 times 3, which is equal to 6. So that means prime of f at 3 is equal to 6. So now we can sub in this value to find the value of prime of h at 2. So that means the prime of h at 2 is equal to minus 6. So this should be the final answer for this problem. Now we can analyze the second problem. So I can use a different color for it. So as per the problem, show that the tangent to the curve y equals x squared plus x minus 2 in parentheses cube plus 3 at the point 1, 3 is also the tangent to the curve at another point. So we have to find that the tangent to the curve at this given point is also a tangent to the same curve at another point. So the first step for this problem is to find the equation of the tangent to the curve at this given point 1, 3. Now we know that tangent is a straight line, so we start with the general equation of a straight line, y equals mx plus b. Now we have to find the value of m and b for this tangent line at point 1, 3. So we start by finding the slope of this tangent by finding the derivative of the given curve equation. So our first step is m equals y prime. So now we have to find the derivative of the given curve equation. Now for the first term, we'll have to use chain rule because this term has an inner function which is the polynomial function x squared plus x minus 2, and in the outer function is the exponential function with the exponent 3. So we start with the derivative of the outer function, and for that we'll use the power rule. So we get 3, so we move the exponent to the front, times x squared plus x minus 2, and then we subtract 1 from the exponent times the derivative of the inner function, and the inner function is x squared plus x minus 2. So as per the power rule, the derivative of x squared is 2x, and the derivative of x is 1, and the derivative of 2 is 0 because it's a constant, and then the derivative of 3 is also equal to 0. Now we can simplify this expression. So we get m equals, so in the first part we get 3 and then x squared plus x minus 2 exponent 2. And in the second parentheses we just have 2x plus 1. Now we have to find the slope of the tangent at the point 1, 3. So we should sub in x as 1 in this expression to find the value of slope of the tangent. So we get 3 parentheses 1 squared plus 1 minus 2 squared, and then m times 2 times 1 plus 1. Now we can simplify this expression. So we get 3 and in parentheses, so 1 squared is 1 plus 1 minus 2 and then squared, and in the second parentheses we get 2 times 1 which is 2 and 2 plus 1 is 3. Now we can simplify the first parentheses. So 1 plus 1 is 2 and 2 minus 2 is 0. So that makes the whole expression equal to 0 because 0 square is 0 and 3 times 0 is 0 and then 0 times 3 is 0. So that means the slope of the tangent at the given point 1, 3 is 0. So now we can sub in this m value in the equation. So we get y equals 0x plus b, which is just equal to y equals b. Now we have to find the b value, and for that we can use this given point 1, 3 because this point lies both on the curve and the tangent line, because the tangent touches the curve at this point 1 comma 3. So we'll sub in y as 3 in this equation. So we get b equals 3. That means the equation of this tangent is y equals 3. Now we have to prove that this tangent that we got y equals 3 touches the curve at another point and is a tangent to the curve at that point. So the next step here is to find all the possible intersection points between the given curve and this tangent line. So for that, we will make this tangent line equation equal to the curve equation and then solve for x. So the equation of the tangent line is 3, y equals 3. So we will sub in y as 3 in this equation of the curve. So we get 3 equals x squared plus x minus 2q plus 3. So this is the equation we have to solve to find the value of x, and that will give us all the possible points where the curve touches the tangent line y equals 3. So first we can subtract 3 from both sides. So the 3's on both sides will cancel each other out. So we get x squared plus x minus 2 exponent 3 equals 0. Now we can apply cube root to both sides. So on the left side, the cube root and the cube will cancel each other out. So we get x squared plus x minus 2 equals 0. So the cube root of 0 is 0. Now this is a simple trinomial, so we can factor it. So we can use the sum and the product rule. So we have to find two numbers whose sum is 1, the coefficient of x, and product is negative 2. So the numbers are 2 and negative 1. So the factored form of this equation will be x plus 2 times x minus 1 equals 0. And now we get the two cases. So x plus 2 equals 0. And from that we subtract 2 from both sides to isolate x on the left side. So we get x equals negative 2. And from the other case, so we get x minus 1 equals 0. And we isolate x by adding 1 to both sides. So the ones on the left side cancel each other out. So we get x equals 1. So we got two x values at which the curve touches this tangent line. Now one of the given points is 1, 3. So this x equals 1 corresponds to the point 1, 3 that's given. So that means the tangent touches the curve at the second point at which the x coordinate is negative 2. Now we have to check whether this line y equals 3 is tangent to the curve at that point or it intersects the curve at that point. So for that, we'll find the slope of the tangent line at x equals negative 2 using the expression for the slope of tangent we got from the derivative of the curve. And that expression was, so I'll write it here. So the expression for slope was m equals 3x squared plus x minus 2 squared times 2x plus 1. So we should sub in x as negative 2 in this expression to check if we get a slope value of 0. Because if we get a slope value of 0, that means that tangent line y equals 3 is tangent to the curve at x equals negative 2 as well. But if we don't get a 0, that means the tangent line is not tangent to the curve, but it intersects the curve at that point. So let's sub in x as -2. So we get m equals 3 and then parentheses -2 squared plus -2 minus 2 and then square times 2 times -2 plus 1. Now we have to simplify this expression. So we can just move this expression here. So we get m equals 3. So in the first part, so -2 squared is 4, and then plus -2 is -2, and then -2 square. And in the second parentheses, we get 2 times -2, which is -4 plus 1. Now we can simplify this expression. So 3, and in the first parentheses, 4 minus 2 is equal to 0 square, and then times -3. Now this expression becomes equal to 0 because 0 square is 0 and 3 times 0 is 0 and 0 times -3 is also 0. That means the tangent line that we found y equals 3 is tangent to this curve at another point whose x coordinate is x equals -2 because we got the slope of the tangent at that point as 0. So that proves that the tangent line we found is tangent to the curve at another point. So these are the steps you have to keep in mind to solve a problem like this one. So the second problem is a bit tricky one, so you have to be very mindful of the concepts related to tangent to a curve. And for the first problem, you just have to use the chain rule for the given composite function. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.